difficult internship. All right, let's see. Does he do lead code? Meeting rooms 3. All right. Each meeting will take place in the unused room with the lowest number. Oh, there's N. Okay. The meeting will be delayed until a room becomes free. The room becomes unused. Meetings that have an earlier original start time should be given the room. So it's saying, I'm guessing it's saying the meeting that hasn't taken place yet with the lowest time should be given that room. Return the number of room that held the most meetings. Oh. Alright, I guess we'll have like a rooms array probably. Times N. One second. Gotta get my fucking long ass hair off the thing. Okay. So 0. So. Oh, and the meetings start in order. Yeah. Allocated. Each meeting will take place in the unused room with the lowest number. When a room becomes unused, meetings have original start. Okay. So this rooms array could be who's using the room at that time, and then meetings per room be the same thing. So these, I guess this one we use for the answer. We'll probably use this while we're processing like the things. So at the end time, it frees up the room. So the room is no. Okay. So this is probably like a line sweep type problem where I process the rooms in the order. So I process the meetings in the order. So I sort by the beginning, right? And then we just put a room into the lowest number meeting room, right? Or we put it in, if there's no rooms, we put it in the first one that frees up. So, okay, so we want to, so that we always take this room from the rooms array with the lowest, so like this rooms array, I guess, could store lowest number, store the end time, store earliest free moment of each room. So the room will be free starting at that time. So this will just be counters return max of meetings per room. Yeah, I guess we'll just return that. Max of meetings. Okay. So maybe this rooms thing is the wrong idea. Like if we want to like I guess always allocate to the earliest room, we probably just want like a heap basically. So when you add something to min heap. and the earliest time will be the one that gets popped like to the top of the heap. So yeah, we just allocate to that room. So like if we have a rooms heap, actually I don't even know how to use heap in Python. Heap queue. Okay, I just say heap. Okay, so this could be a heap. Oh, okay, cool. So we have this heap, which I guess I might have to remove some variables in a moment. Okay, so then I guess like meetings dot sort. I think that's how you sort. Okay. Okay, this one's in place. Okay, cool. Oh, and then we need a second heap for this thing. So when a room becomes unused, or no, this one, yeah. So if there's no available rooms, we delay a room. Okay, so we need to put on this heap the yeah, in this heap we need to put the. Bro, I'm retarded. I can't think of this. Oh yeah. This heap we'll just put the like if rooms are delayed. Actually, do we need another heap? Hold on. I'm not sure if we need a second heap for that. I don't think so. So I'm thinking like if we process them in order, right? Like this one will have a room, this one will have a room, this one won't have a room, so we can just wait. We can just pause. Yeah, we can just pause until a room frees up, and then we put it, and then we keep iterating this. Okay. So yeah, so for meeting in meetings, earliest or free room equals rooms heap dot pop heap pop. Might have to change this. So like it'd probably be the time. Yeah, I guess I should write this down. So it would be time because we want the earliest time, comma, meeting index. So we'll just start 0, 0 first, right? Never mind. It's gonna be 0, I for I in range n. Okay. No, but these rooms. No. So room index. Okay. So earliest free room, rooms.heappop. Time, free time, and earliest free room. So if meeting so if the meeting time if meeting I think I can actually split this up. So the meeting start, meeting end. So if the meeting start is is greater than or equal to free time. I'll just say time room is free. That's more descriptive to me. Time room is free. If the meeting start is greater than or equal to the time the room is free, then we can just rooms heap dot heap push meeting end, right? And then else, so this would be meeting start is less than time room is free. Then we have to delay, so rooms heap dot heap pop. Wait, I think I might be using the heap thing wrong. First we'll have to from collections import heap queue. I think it's like heap queue dot heap pop rooms heap. Okay, I think that's right. Heap queue usage. Yeah, okay. Earliest free room. So this should be the time that the meeting ends. I think it's plus the difference between when the room is free, or no, it should just be when the room is free, plus the time elapsed of the meeting. So, time room is free plus something, comma, earliest free room. And like for this. So the time is room free plus the time the meeting takes. So I'll say time elapsed meeting time should just be the end. So should just be the end minus the start plus 1, I think. No, the end minus the start. So yeah, meeting end minus meeting start. And then it should be plus elapsed meeting time. I think that's good. Yeah, and then I guess so. Meetings per room plus equals earliest free room plus equals 1. And then we return the max of the rooms. All right, let's see if that works. Runtime error. Am I tripping? It's just import heap queue. Okay. Okay, what went wrong here? Print rooms heap. Oh, we return the index of the room that used the most. Okay. I'm stupid. If meetings per room greater than equal to earliest free room greater than equal to I'll just call it answer. Meetings per room answer. Meetings answer equals earliest free room. And then we return answer. Wrong answer. Oh man, bro. Expected 0. Should probably just be greater than. Oh, shoot. Wait, what am I supposed to submit? Or wait, let me add the test case here. How do I do that? Use test case. The number of the room that held the most meetings. Oh. So maybe I could just keep a the easiest way to do it would be like it would make the most sense to keep a heap of that, but I think I could just like iterate over it at the end, to be honest. So I'm gonna just like remove this answer part and just be a chud. Yeah, I'll do that. Zero, so for I in range n meetings per room I. Yeah, so if greater than this is probably just equivalent to what I just had, to be honest. Oh, maybe it's not. Okay. So I'm gonna say meetings.sort happens in place, right? Print meetings. So this should be correct. Use this test case. Okay. So I must not be following the rules right if I'm getting something wrong. The unused room with the lowest number. So wait. I think I'm choosing rooms the wrong way, I guess. I need to choose rooms with the lowest number that are available. So, I guess I somehow need to keep track of the. I guess I need to keep track of the rooms that are active and the rooms that are inactive. So probably two. Like my initial thought was two binary search trees, but I'm guessing like if I could do two binary search trees, I could probably just use two heaps. So I'd have one. Yeah, so one heap, that's the minimum of the. Yeah, okay. So one heap that has the minimum room number of the active, or like the available, um, yeah, of the available rooms. So that one always chooses the lowest number. And then I have another heap that's the earliest times among the. Yeah, the earliest times among the rooms that are being used. And then when I iterate to a new um when I iterate to a new meeting in this loop, I pop all of the used rooms from the used heap that are, I guess, like expired and like not being used anymore. Okay, so this is gonna be like a little bit different. Actually, a lot different. So yeah. So we have a rooms heap. All right, so we're gonna change this from rooms heap to available heap and used. I'm not even gonna name this as heap. Available rooms, used rooms. And this is gonna be the same. So for the available rooms, we want this to be room index time. And then for this one, we want. Hold on. A room becomes unused. Yeah, okay, I think that's right. So we'll leave it as is. If there's, yeah, exactly. Okay. So I think everything I have now is right. So this will be, so this one is room index time, and then the used rooms is time room index. Okay. I think that's right. So then in this case, so if there's available room, or no. Yeah, okay. So when we get to a new meeting, the first thing we do is pop all of the used rooms that are now available. So while used rooms and used rooms top, is that a thing? Or used room 0 is less than or equal to now. So meeting start heap queue dot heap pop used rooms. So this will be time room index heap queue dot heap push. Now we put it in the next queue. Available rooms. Room index time. Okay. So at this point, the available rooms thing is in the right spot. Okay. And then we always, we're going to use this room. So room. So we're going to call this meeting room. Is meeting room, meeting, and then, yeah, okay, that's fine. I guess like available in theory could be empty. So yeah, so if available rooms, so there's two cases. So if there's available rooms, then we just take the first room and we start the meeting. So meeting selected room would just be available or heap queue dot heap pop available rooms. And this would be comma selected. Yeah, let's just call it time for now. So if it's an available room, like we just start the meeting. And I'll define this. So elapsed meeting time is meeting end minus meeting start. Yeah. So then we'll put in. So we'll add use, or we'll push this into the new heap or the used heap. So heap queue dot heap push used rooms, because we're now using it. Then it'd be time plus elapsed meeting time, and then room index, which is selected room. Okay, I think that's good. And then else, so that means no available rooms. We have to first pop. Yeah, we have to pop from the yeah, we just pop one from the use rooms and then use it. So yeah, okay. Selected room, comma, or time, comma, selected room equals used, or heap queue dot heap pop used rooms, and then we'll add it back to the queue. Yeah, heap queue dot heap push time plus elapsed meeting time. Selected room. So this is gonna be used. Oh shit. Shit, my alarm went off. 1 second. Okay. Okay, I think that's right. So then we just do meetings. Yeah, we just do meetings per room. Selected room plus equals 1. We do this here. Let me try that. Runtime error. Yeah, in used rooms, the top of the thing time, so it should be 0. Wrong answer. Okay, you know what? I'm gonna get my laundry first. Okay, I'm back. Time to lock in, bro. Okay, what's wrong? Print it right here. Okay. All the rooms are available. Wait a minute. Why are the available? Oh, it's printing the. Yeah, okay, that makes sense. Oh, it's because it goes to n-1. Why is there 3 available rooms? Oh no, n is 3. Okay, that makes sense. Yeah, so the first one goes there. The second one goes there. Wait, no. The first one goes here. Second one goes here. Third one goes here. Right? So these 3 are available. at time 4, there shouldn't be any available. Because the time... Hold on, that doesn't make sense. Why is 04 available at all? Oh, wait, I have these backwards. I think there might be another issue, though, as well. Yeah. Okay, that's one thing. I think, was it this one that was wrong? Yeah. Alright, that's fixed. But the time is wrong. Because the time should be... So it's not that the time is... It's not for the time of the available room. It should be the time... It should be the start time of the room. Okay, wait. It becomes available. Sure, I can get behind that. This is the time that's free, so we pop it. But if the room is available, it becomes available at this time, but we want to use... Really, it should... This one in the used room should end at the meeting end time, I think. There we go. Let's see if this fixes it. There we go. 11%. Holy shit, I'm ass. Oh, I have a print statement. I'm a fucking idiot. Okay, let me get rid of all of the prints. See if my thing gets better. Ooh, okay. I didn't know I was tough like that. I did not know I was tough like that. Alright, cool. Later.